All right, we're ready to go. Welcome, everyone. Thanks for joining us. I'm Francois Martel from Newbird, and my friend here, Dheeraj, is from Microsoft and will lead the presentation. So thanks for coming. Thanks for your time.
Yeah, super excited to have everyone here. Like Francois said, my name is Dheeraj and I'm from Microsoft. So today we want to talk to you about how we are building agents, a multi-agent architecture to help solve beyond the single cloud SRE. So for any customers, any architectures and systems that have more than one cloud involved. So obviously, as SREs, we all know there's a time pressure. Production crises demand immediate response, and every minute has downtime costs. For our support teams, finding out where these issues are often is complex when we have more than one system, whether it be on-prem, multiple clouds, AWS, GCP, etc. And so we need to help figure out how to reduce that time to mitigation. Manual investigation often works. We have this concept of tribal knowledge at Microsoft where not a lot of our stuff is maybe documented as well as we'd want. I know a lot of different people face the same issue. And so traditional manual troubleshooting is often slow because you have to find the person, the SME of the system that has gone down. And the person that's on call might not be that person. And then we have the cross cloud complexity. The one that Francois and I will demonstrate today includes having two major cloud providers where one of our systems is in one of them and the other one's in the other. Our alert will alert us that the Azure system is maybe the one that's facing an issue, but the root cause is going to be in this other cloud. This type of scenario often amplifies the challenges of the time pressure and manual investigation because now you need an SME of both clouds, oftentimes, which are two different teams, and have two different sets of toolings and two different sets of logs and two different sets of everything, often increasing the amount of time it takes for us to actually resolve the incident. So our vision is to build AI agents that collaborate. We've all heard of these. I think in the keynote they mentioned MCP servers for one of the startups that presented up here. Collaboration between AI agents, more than the transport protocol, is understanding how the strengths of those agents can play into each other without hurting each other's ability to function. We often run into this huge issue of too much knowledge or too many tools. And so our goal here as we engineer this multi-agent architecture is to ensure that we don't have this duplication of a function. At the same time, we are able to both use the strengths that our agents have. Additionally, we both have integrations with real-time detection. We don't want to reinvent the wheel. We're integrated with all the ICM platforms, so if there is a crisis, we want to rely on the teams to set up the alerts that are involved. Finally, it's the cross-cloud SRE. This is an innovative approach. I don't think anyone else has done mitigations across multiple clouds, and I think that's the key word here. We're not just suggesting a solution. We're going to go ahead and try and mitigate any downtime that would happen, even if that happens outside of Azure. So I want to quickly introduce the two agents that we're going to demonstrate today. We got the Azure SRE agent. This is Azure's agentic solution to help teams diagnose and resolve production level issues. We have a couple different modes. The first one is the always on mode. This monitors your performance and health and security of your apps 24/7. Say someone pushes a security vulnerability, they put up a new key. That's not supposed to happen. SRE agent would be able to follow that and alert anyone that's on call. Finally, we also have incident management mode. This is, again, these are the incidents that your team has defined as something that needs to happen. So this could be any sort of incident that goes into PagerDuty, ServiceNow, Azure Alerts, 500 errors, whatever your team defines as an incident. This will be triggered by those alerts that are set up by the team, and SRE agent will go and find an RCA for those incidents and resolution steps when possible. If those resolution steps are actionable by SRE agent, it will go ahead and take that mitigation. Finally, we do view the SRE agent as an integration hub. There are so many agents out there, especially in the SRE space, and we want to make sure that we're integrated with all of them. We believe in this whole agentic web. Hence, starting with Newbird, we've created this integration where we don't want to reinvent what Newbird has made per se. We want to use all of the different data sources that Newbird has access to, whether it be your data observability is in New Relic or Datadog. Whether your other network management tool is in AWS, Azure SRE agent is able to consume all that information before taking the resolution steps. Now I'm going to let Francois talk a little bit about the new bird.
Thank you, Dheeraj. New Bird is a startup. We're seed round funding by Mayfield and Microsoft, and we're partnering with Microsoft on this solution. What we've built is an SRE agent that really specializes in root cause analysis. And the company was founded by SREs and platform people, as well as AI specialists. And what we've done is the first thing we built was actually a data layer, because our job is to do context engineering, to provide the right context to the LLMs so they can reason about your problem. Our job is also to fit into your workflow. So you have ITSM, you have PagerDuty, Slack, ServiceNow, you have a workflow. The last thing you want, and I love the keynote this morning, you don't want yet another tool that will have its own learning curve. You want to keep using the tools that you have, right? And so we fit as a layer on top of your existing observability investments. We're just querying those tools. So if you're using, it doesn't matter if they're on-prem or cloud, right? If you're using Splunk or Elastic or Datadog or Prometheus, we can read that information. We're not copying it anywhere. We're just reading it in the context of an investigation that's been triggered by your ITSM solution, right? And we're reading it in order to do root cause analysis, explain what's going on, and provide a recommendation for what to do next. And in that process, we leverage your institutional knowledge or tribal knowledge in the form of instructions that you can provide to Hawkeye. And we're also leveraging your LLMs. So this whole solution can actually be deployed in your Azure subscription using your LLMs and your networking. A lot of people have issues with trusting LLMs, so this gives you full control. We could also obviously run it as SaaS. And our vision is that we need to collaborate with other agents out there on both ends, right? Other agents calling to us for this root cause analysis for things that they require, but also us calling to other agents. So for example, GitHub Copilot has way more visibility into code and code repos than we could ever try to accomplish. So we'd rather call on them to help with code level explanations where we focus on tracing logs, config. We tie into your CI/CD to tell you which pipeline deployed the change that caused the problem, but we're not going to go and do deep code level analysis. Similarly, I'm presenting on a webinar next week with a partner doing database agents, right? So there's an ecosystem out there that's developing around agents that we want to be a part of.
So with that being said, those are the two agents we want to demonstrate. This is what we're building. In order to prove that we work together, we have this live demo. We have a critical error that's going to be detected by a ServiceNow incident. That multi-cloud architecture we show is going to have an Azure front end and an AWS back end. Once the ServiceNow incident is triggered, we're going to have Hawkeye do an investigation, and we're going to have that information combined with the Azure SRE agent's investigation. Together, they'll go ahead and collaborate on one single resolution, post that in a common space, and go ahead and take a mitigation. Let's see. So here we start. This is the Azure SRE agent. In the SRE agent, we're going to create what we call an incident handler. This is part of our incident management platform. We get to set up where our incidents are coming in from. We have support for PagerDuty, ServiceNow, Azure Alert. Right now, we're going to go ahead and do ServiceNow. This is, again, like Francois said, a place where you can put in your tribal knowledge of what you want a particular incident to act like. You can also select the specific tools that the agent has access to. Again, we don't want to give agents all the access in the world. In this case, the engineer that built this, has selected the Hawkeye-specific tools. Now that those Hawkeye tools are set and we have the custom handler set up, we're going to go ahead and manually trigger a ServiceNow incident. This is just a demo, so we're writing in demo incident just to show you that it would work regardless of how the ServiceNow incident is triggered. So once this is triggered, the Azure SRE agent consumes that incident just as any SRE would. What Azure SRE agent also does here is makes a call to Hawkeye, which also consumes the incident and has already started an investigation in parallel. So with that incident, you can see here that SRE agent is acknowledging the incident itself and going through its execution plan as defined by the user. And it's getting the investigation from Hawkeye. It correlates the session ID to find that Hawkeye is already working on a similar investigation. And now it's going to go ahead and return the information from both agents. Hawkeye found that it was an AWS API gateway issue. That was not part of Azure SRE agent's investigation. Azure SRE agent found out that there was an issue with the Azure resource itself. This gets us a step closer to the true RCA of our system. We can see here that Hawkeye also provides some resolution steps, which SRE agent is going to go ahead and take and put into a shared memory layer, which I'll talk more about in a second, right after we finish this demo. A lot of messages here. But you can see finally the investigation findings have been summarized, and they're going to go ahead and be put into the ServiceNow discussion. So we're going to go to our ServiceNow incident. We're going to find the incident number of the incident we just created. And you can see here, Hawkeye and Azure SRE agents combined analysis and resolution plan is put into the system discussion. So this is just one of the ways these two agents could have collaborated on this incident. And it again depends on the user settings and user configuration. Another way, we'll go into that in a second. Francois, is there anything else you want to add on this demo?
One thing that I want to highlight is how incidents and alerts are great prompts, right? So if you give an SRE a chat bot interface and they go type in questions, it's hard for SREs to really give enough context for a useful investigation. And alerts are absolutely wonderful because they have the metric that triggered the alert, they have the alert configuration. There's a lot of rich context that Hawkeye can leverage to go perform the analysis required to resolve the problem. And so the key to an agent is that it should work in the dark. And our vision is for the results to show up where you work, right? You work in ServiceNow, right? So the results are available here in ServiceNow, and everything happened in the background. Watching the chat interface is not as interesting as just showing up and having the info you need to do your job. So that's the vision for agents, is not only you should have the info, but then Microsoft's SRE agent can actually orchestrate the remediation that Hawkeye, and that's, I think, super exciting because then your job is already done for you.
100%. Based on that, I want to give a little bit more insight about how we built this and how these agents collaborate behind the scenes. So this was the demo application that we were working with right here. We had the Azure AKS system in the front that was communicated, that was analyzed by the SRE agent, and we had Hawkeye analyzing the backend and the entire stack, but mainly the backend added, augmented to the agent's knowledge. So agent communication, right now we're able to securely communicate all that data. You saw we were able to make that call. Again, just a protocol choice here, but we decided to go with an API-based communication just because it worked. We could go ahead and upgrade that to MCP, etc., but we wanted to just have secure communication one way or another. The LLM-powered hypotheses. So all of these hypotheses have a different confidence scoring for us in Azure SRE agent, and we often pick the one that has the highest. But in incident management platforms, we want to give users the ability to look at the other options and other confidence level hypotheses that were created. Finally, we do have safety mechanisms. You can always roll back. There are multi-layer approval workflows. This was a demo, so we put it in fully autonomous mode, but we have different modes where the agent does not take action at all. And then I also want to talk about the shared memory layer. So in this particular demo, our shared memory layer, if you would have it, would be the ServiceNow issue discussion. This is where both Newbird and SRE agent would theoretically have access to the analysis that was made. What this allows us to do is make multi-turn analyses in case this error ends up being more convoluted than expected initially. How we navigate these multi-agent handoffs and collaborative workflows is actually fairly complex. One of the biggest issues with handoffs is figuring out which handoff to make and when. Azure SRE agent, and like Newbird, you saw in the architecture, have multiple tools at their disposal. A lot of them are also agents and have generative AI tools that span their own amount of tools. We need to ensure that there's consistent handoffs, and we need to know when to make the right call. In order to do this, we need to have the right context and preservation. If you saw in that custom handler that we set up, D made sure to call out certain things. For example, the system's architecture had some external dependencies. You don't need to know what those external dependencies are, but because we've noted that there are external dependencies, we're able to make a call to NewBird because we know that NewBird has access to telemetry for the entire stack. In order to prevent tool saturation, we also in that custom handler had the ability to pick the tools we wanted for this specific incident. Oftentimes we've noticed that when our agent has access to the full plethora of tools, it has an option to pick the wrong tool. And we have our evaluation sets, and I'm going to go into that as well right here down below. But the best way to prevent an error is to not give it the option to make an error. So we hand off to NewBird when we can, we hand off to other agents when we can, but we also do ensure that not every incident needs access to every single tool. That also goes back to our security. For example, like we don't want some sort of security setting to get changed randomly, etc. So we ensure that not every single incident has the ability to make certain changes. That being said, how do we test this end to end? So this is a very demo. We're still working on putting it into prod, this particular integration. But in general, we have a holistic testing set. We have 3 different tests. We have an online evaluation with the LLM as a judge that runs for every single change we make. We have what we call our intent scoring, where another LLM will come in and be like, was the intent of this particular request met? In this particular case, was that issue resolved or not? And so this additional LLM as a judge would definitely do that holistic testing. And then we have 2 offline tests where we go ahead and we build these end-to-end environments where we talk about, for example, did it make all the right steps? And we define that in a golden scenario. For example, if a customer has an intent to test a system that has an external dependency where like 1, the SRE agent should run its own evaluation. 2, it should make a call to NewBird. And 3, it should resolve the issue by posting it to GitHub or ServiceNow or any of these other shared memory layers. So these are predefined test suites, much like you have in traditional software engineering. We also have performance metrics. These define clear success criteria. This would be like tokens used, time to mitigation, time to response, how many things are cached, etc. And then that also includes our success intent met percentage. Finally, we're always iterating. A lot of these handoffs are declarative descriptions of what the tools are. And so if the handoff is not happening the way we want it to happen, the simplest way to go fix that is to make a more descriptive handoff description, etc. This could also be within our agent as well. A lot of this is prompt engineering at the end of the day. That being said, I've said this term quite a bit, and we call it shared memory. And I'm like super excited to talk about this one because this is what really differentiates multi-agent architectures versus single-agent architectures. Within a single-agent architecture, the system has context on everything that's going on. But when you bring in another agent that you don't control, how do you continue to share memory, especially once actions have already been taken? And that's where we can actually leverage existing tooling. Practical memory stores, for example, include GitHub issues, ServiceNow, like the demo showed, Azure DevOps, workload, work items, Jira tickets, Slack threads, wherever you currently share context. I'll talk about GitHub specifically. The future of this partnership that Francois and I are talking about is we're going to have all those analyses go into a GitHub issue. Then we're going to hand that off to GitHub Copilot, which will start a PR. That's when a human can step in, approve or reject the PR based on what the issue was and what the resolution GitHub Copilot took based on the suggestions from Azure SRE Agent and NewBird. Now, once all that's done, say the same exact incident pops up again. How will these agents effectively address this issue again? If they did not have context and this memory store of what had already happened, they might take the exact same steps again, and it might be a short-term mitigation, but we really want long-term mitigations. That's the reason we would want to hand this off to GitHub Copilot, because we want to make code-level fixes. And so having the ability to have this shared record for the agents themselves looks very similar to how we keep track as devs and SREs. And so I think in a lot of different communication protocols, we get caught up in how we actually communicate between the different agents, with whether it be MCP, A2A, API. But there is a level above this where it's like, how do we keep the context in all those transfers of different agents? So that's context retention, adaptive learning. Like I said, now the incident happens again. We have a shared record of this, and potentially that will lead to better outcomes. And over time, that will build institutional knowledge in the agent itself. It also provides us, say you're a support engineer or someone that maybe isn't directly involved with the product development, you're on call and you're like, hey, this incident happened 3 months ago. What happened? Like, how did I fix this before in this other system? And now your agents both have access to that information.
Yeah, a couple of points. One is I love this vision because that's where we work every day, right, as SREs. And so SREs can participate in this shared memory model where the agents and the humans are collaborating, right? When we post to Slack, you can answer in Slack and get a response from the agent. I also think that the point you made about the outputs of the LLMs themselves can then be used for, or the agent output, right? The root cause analysis. In Hawkeye, root cause analysis are very detailed and structured. And over time, if you have Hawkeye investigate 1,000 of alerts over a period of 3 months, then you can start looking back at this detailed information. It's much easier to learn from the root cause analysis information that's in narrative form versus the raw telemetry data in your observability stack, right? So we investigate, we create a narrative of the problem, of how it occurred, what was the underlying causes, and what the suggested fix is. And that becomes part of something that over time you'll be able to mine for further insights, not just the agents looking at it, but you and your team looking at it over time and learning the deeper things that are going on that are causing all these alerts.
Awesome. And so I want to close off with the declarative agent configuration. I already alluded to this during the handoffs. The same way we declaratively handle handoffs and make sure it's all descriptive, we also need to be very clear about our prompt engineering, crafting precise prompts to ensure that the agents are handed off properly. Orchestration logic is another whole other slew of tooling and suites that need to be built. I think within our system, particularly, we don't use one of the pre-built orchestrations. I don't think that's always necessary. We do want to treat this as any other distributed system. We want to make sure there's the ability for retries, that there aren't any issues when it crashes, that it is able to pick up right where it picks up. Utilizing tools would help, but we don't. And I think that's fine as long as we have a way to test our system end to end and we do have the ability to be resilient.